We have already seen that for a circular aperture of very small diameter, light will diffract outwards in all directions, creating a pattern like you see here, with a central bright disk called the airy disk, surrounded by several progressively fainter secondary rings. For circular apertures, the angle that the first minimum is located at is given by the equation theta of the minimum equals 1.22 lambda over d, where d is the diameter of the aperture. That is the angle from the center of the disk, so the theta equals 0, to the first minimum in any direction. The factor of 1.22 is due to the circular shape of the aperture, and you don't need to know how that was derived. The central airy spot is an important thing in describing the quality of optical instruments. Lenses and mirrors act as apertures, and the smallest spot to which any lens or mirror can focus a beam of light is the size of the airy disk. You can see from the equation here that to get a really small airy disk, you need theta min to be very small, which means that the diameter d should be as large as possible. I'm going to show you now an actual diffraction pattern from a circular aperture. Now, before I do any demonstrations putting anything in front of this laser, I just want you to see the pattern that you get simply from the laser beam itself hitting the screen, because you can actually see, and I know you can't see very well in the live footage, but I'm going to put up a still photo that's more of a close-up so you can have a look. And what you can tell is that even though there is nothing that I've put in front of the laser, there must be a circular aperture in there. And the reason you know that is that when you look at the pattern close up, you actually see the concentric rings that are the typical circular aperture diffraction pattern. You can see the one at the center is by far the brightest, and it's also quite a big diameter. And then you have fainter and fainter circular fringes around the outside, and they're narrower than the bright spot at the center.